Okay, so hopefully you can all hear me, and apologies for speaking in English. So welcome everyone. It's really great to be here all the way from Google San Francisco. And essentially today we're going to cover the world of client-side AI and even the potential future of the internet itself as we embrace and scale in the agentic era that we've already been living over the past year or so. So to kick things off and to learn a bit about who I am, and we're going to head over to the client-side AI community to see what they've been up to. These are people just like you, but are already using machine learning in JavaScript in their products and services to give you a taste of what's been possible for many years already, just to bring you all up to speed. So with that, we're going to play the video to kick things off. Hello everyone, I'm Jason Mays, Web AI Lead at Google, for our teams that focus on the art of running machine learning models client-side in the web browser. I made a prediction that websites of the future may need to be AI agent platforms, so that you could talk to them naturally to perform anything task that they support in useful work done faster. In 2024, the Web AI community has progressed towards a smarter web to show you a glimpse of a possible future of the internet itself. But what about going the idea prototype faster in our new collaboration with Agentic to a date of the future where you can go through visual blocks or no-code framework and have it build a pipeline for you in seconds using our latest design applications?
That's what you see. You took all these tracking points in space, and you can track it with and without classes. It has an incredibly high frame rate, even in JavaScript and in browser.
So you're looking at using satellite as well as joining UAV imagery to recognize objects.
You can send a link to any picture, whatever the PT has to do. We can have a race, we can show them the wrong age,
What's the word which enables multilingual transcription and translation across 100 different languages. Last year, we partnered with several Asian beauty brands to bring their products to users' mobile browsers.
I made the Web AI DJ in just one day that works with public APIs for user services. Everything here is running entirely locally from my laptop PC, meaning there'll be no input costs involved. By performing the platform blurring on the client side and Web AI across code way, there are very few opportunities in one site. We're at the beginning of a new era of this, because anyone watching here has a chance of a lifetime to shift the future of the fast-growing space. I hope all of you will join me on this adventure. All right, so some pretty cool demos there, right? But why should you care about Web AI? Surely you can do all of this up in the cloud, right? Well, you can get some superpowers that are just not possible with a cloud alternative. Now, I know you all come from very different industries, so think about how any of these, how any of these could apply to yours as we go through them. First up is privacy, as no data from things like the camera, microphone, or even text need to be sent to some remote AI model on a server, which protects the user's personal data. And a great example of this is shown here by Include Health, who use browser-based pose estimation models to perform remote physiotherapy without sending any imagery to the cloud. Instead, only the resulting range of motion and statistics from the session are sent, allowing the patient to perform the checkup from the comfort of their own home, whilst also protecting their privacy. And you've also got the ability to run offline on the device itself, as you can even perform tasks in areas with low or no connectivity after the page load. Now you might be wondering, why would a web app need to work offline? Well, in this great example by Hugo Zanini, he performs a product placement verification using a web app in supermarkets for a retail customer that he was working with. And we all know how bad data connections are in large metal structures like supermarkets. He leveraged TensorFlow.js to run a custom object detection model right in the browser that can work entirely offline and then syncs data back when a connection is available later on. Now you can imagine applying similar techniques to retail analytics solutions to monitor what objects are most interacted with, or maybe even within digital kiosks in the aisles of the supermarkets to understand how busy an area is at different times of the day. Or what about healthcare solutions for pharmacies to count how many pills there are in a prescription, and much, much more, all working offline to conform with regulations. Next is low latency, which can enable you to run many models in real time, as you don't have to wait for data to be sent to the cloud and back again, which might be significant if you're on a mobile phone data connection, for example. As such, many of our models, like these ones from MediaPipe for body pose and segmentation, can run at over 120 frames per second on a mid-range laptop's graphics card, with great accuracy, as you can see on the slide. And you've also got lower cost, as you don't need to hire and keep running expensive cloud-based graphics cards and processors. Which means you can now run generative AI directly in the web browser, like this large language model on the left, without breaking the bank. And we're now seeing production-ready web apps benefit from significant cost savings, like the example shown on the right, for advanced video conferencing features, such as background blurring right in the browser. And even better, you can offer a frictionless experience for your end users, as no install is required to run a web page. Just go to a link and it just works. In fact, Adobe did exactly that here with Adobe Photoshop Web, enabling anyone, anywhere, to use their favorite creative features on almost any device. When it comes to the object selection tool shown on this slide, embracing client-side machine learning for this feature can provide Adobe's users with a better user experience by eliminating cloud server latency, resulting in faster predictions and a more responsive user interface. And finally, you can leverage the reach and scale of the web itself, that has around 6 billion browser-enabled devices potentially capable of viewing your creation. All right, so let's take a video conferencing solution as an example, but you could imagine this for other use cases too, that might also stream audio or video data, maybe for healthcare, security cameras, and beyond. Many of these services provide background blur or background replacement for privacy. So let's crunch some hypothetical numbers to see the value of using client-side AI at scale. First, a webcam typically produces video at 30 frames per second. So assuming an average meeting length of 30 minutes in length, that equates to 54,000 frames per meeting that need to have the background blurred. So assuming 1 million meetings per day for a popular service, that equates to 54 billion segmentations every single day. Now, even if we assume an ultra-low cost of just 0.0001 cents per segmentation, so very low, that would still be $5.4 million per day, which is around $2 billion per year for server-side AI model inference costs. By performing the background blurring on device in the web browser with web AI, that cost completely goes away. And don't forget, you can even port other advanced models to the browser, like noise cancellation, to further improve the meeting experience for your users while reducing costs even more by running all of those features on device. Okay, so now you know the 101. Today, I've come to share a story about the potential future of the internet itself, an agentic internet, that I've been looking into over the past year, and why you should also start investigating agentic behaviors on device within the browser in JavaScript to gain extraordinary abilities for your existing web applications, as users' devices continue to get more capable as we move to a world where the internet is optimized for both humans and agents alike. Now, back in 2024, the web AI community progressed towards a smarter web that was more powerful than ever before. Like this prototype that I made that enabled videos to literally watch themselves for you, extracting useful video frames that matter in real time and could even work offline. In this demo, you can see that I asked it to find the frames with the words Jason Mays contained within them, or a person standing on a plane, one of my hobbies when I'm not nerding out on web AI. And sure enough, it extracts them along the bottom for me, all in real time, entirely client-side, no server calls required. But this, while smart, was not an agentic behavior. So what's an agent? At its essence, an agent is a system that can perform tasks autonomously on behalf of the user by breaking them down into structured steps that it can then complete without user intervention. An agent can dynamically select and use exposed tools, potentially many times in a loop, allowing it to interact with the outside world, filling in any missing knowledge that it may need to perform an external action, and then complete each sub-step beyond the constraints that the core language model might actually have. That's ultimately driving the agent's internal thinking and logic. So let's dive into this tools concept a bit deeper. Well, language models contain a vast amount of knowledge about the world around us. If you ask one what the weather today is in London, it will likely hallucinate an answer that's probably wrong, based on its training data that's stuck at some point in time in the past. Instead, you can expose a tool that fetches the current weather for a given city that the language model can choose to call with the inputs it needs to get up-to-date information about the weather and then use that response in its own contextual history to perform the task correctly. And tools allow the language model to bridge the gap between itself and the outside world. And an agent can potentially use many of them to interact with various external data and services, unlocking more powerful actions that could be used to help it solve the goals set. Now, in the example shown here, this illustrates some of the tools you might expose for a holiday planning agent. And common types of tools include calling a function to perform some task, or taking an action by an extension to use an API, or fetching relevant contextual information from, say, a vector data store somewhere else. Next, with regards to the language model used, this could actually be one or more large language models, or even multimodal models, to understand inputs beyond just text, that are all capable of following instruction-based reasoning. Now then, if multiple models are used, the orchestration layer may decide which one to delegate to for the current sub-step being performed. Essentially, an agent can plan and define subtasks that it needs to get a job done, choosing the appropriate tools at each step, and then whose output can be used as extra context in its own memory to then reason what it needs to do in future steps in order to complete them without constant human intervention. And it might even choose to cycle through a chain of steps that it chose to perform potentially multiple times, breaking the task down further to eventually complete the request. So, bringing this all together, an agentic system is typically comprised of one or more language models, a memory implementation, and one or more tools it can choose to call. And these key subparts are managed and coordinated by the agent runtime, or the orchestration layer, if you will. So, how does all of that turn into web AI? Well, last year I made a prediction that websites of the future may need to be AI agent compatible, such that you can just talk to them naturally to perform any of the tasks that they support to get useful work done faster, without needing to learn arbitrary user experiences on different websites. I also predicted that sites that don't make it easy for agents to work with them might struggle to compete in the modern agentic AI age, just like how we had to support mobile versions of our websites in the past to stay competitive when the smartphone was invented. And today I'm going to demonstrate a web AI prototype that puts those agentic concepts into action to show you a glimpse of a possible future of the internet itself, whereby websites are designed to work interchangeably with agents and humans alike. Now, I'm going to be using Google's Gemma model that runs entirely locally in the web browser, powered by our MediaPipe Web LLM library, to show you how you can upgrade your existing site with agentic workflows by reusing your existing code exposed as tools that we just spoke about that the agent can use in a low-friction manner. Now, I'm also pleased to announce that we've also got our Gemma 3 models converted as well. And as you can see from the table, all the smaller models up to 12 billion parameters are much faster than reading speed in terms of the tokens per second that they can produce. And just for fun, we converted a 27 billion parameter model as well that can run roughly at reading speed if you've got enough GPU memory on your machine. Now, while this latter example might not be a mainstream use case, given its very large download size, it does show that you can run a 27 billion parameter model entirely locally in a web browser for niche custom situations, whereby you might want to run it on the client side for privacy or cost savings, maybe at a doctor's office or something like this. So I'd just like to point out that the 3N models are also multimodal, which means you can now use text, audio, or photos as inputs to those models. And then you can ask questions using natural language about those inputs too. And you can see from our screen captures on the right-hand side some of those things in action. And at any point in time, these have effectively 2 billion or 4 billion parameters activated, which means we can run them on quite a large variety of machines without too much trouble, and are still very, very powerful. Okay, so if all websites embrace these concepts, we can enable a smarter web for everyone. Everything you're about to see is captured in real time on a 5-generation-old NVIDIA 1070 GPU, which is quite old now. So these things will likely get faster with time too. Let's roll the video.
In this demo, we will simulate a flight search page similar to Google Flights to illustrate how this agent would work. Let's go ahead and attempt to book a flight using the AI agent microphone button exposed, but purposely not giving up information. Hey there, I'd like to go on holiday with my friend.
Where are you departing from and when? Is that a one-way trip?
Notice how the agent has already figured out that 2 people are likely going on this trip in the JSON output on the left. However, it also realizes that in order to use the website search tool, it needs more data to pull that. So it's asked us a follow-up question too. Let's respond to what it wanted, but also include more data than asked for to show how to adapt to anything that the user throws at it. We'll be leaving from San Francisco, but can you pick up a popular skiing destination in the French Alps for us to go to? We'll leave on the 5th of December and come back 1 week later.
What is your preferred destination in the French Alps?
I don't mind. You pick a town that's good for skiing in the region. So as you can see, even though I spoke to it quite a bit, it successfully extracted the data information, figured out what 1 week later actually means, and suggested a popular skiing destination of Chamonix, which is a great choice. As it knows that it now has enough information to perform a search, it goes ahead and pulls the search tool with the data. Now for this demo, just for fun, I'm feeding in the LLM to generate fictional results too, just to show you how much knowledge of the world this tiny 2 billion parameter model has with no tuning. So at no point in this demo did I send any of the data back to the cloud, although in real life, a search will probably end up calling your cloud API to get the latest results from a real flight database. As you can see, it generated some realistic flight options, including some European airlines. Alright, now we've got some results. Let's show how versatile this is. You know what, we had a change of plans and an extra friend is coming, and we decided to go to Tokyo instead. As this is a special trip, let's make those seats business class, baby, and change the dates to better dates in autumn. So here, I'm going to get increment the passenger count at 3, set seats to business, and destination should become Tokyo. I'm also going to put some dates in the September to November range, and sure enough, it seems to work. Now, as I said, everything here is running entirely locally on my laptop CPU, meaning that you could talk to it all day long and there'd be no input costs involved. The only cost here is the initial download of the language model based on its size and the CDN provider that we're using, which is a one-off and it's capped at region page loads.
All right, and speaking of caching, I've also created a useful caching proxy library available on the link shown that you can use when fetching large files like AI models from the server in just a few lines of code. So feel free to reuse this to save you some time in your own creations as well. And this is how easy it is to interact with existing website functions you've already written. As you've seen, this can lead to a much more natural user experience that's more natural for the user versus having to learn a new user experience for every website that they view. Not to mention, even a visually impaired person could use this interface too, using just their voice, making the website more accessible as well. So pretty cool, right? If you're wondering how this all comes together, this diagram shows the key data flow for what you just saw. And the key thing to take note of is that the agent orchestration logic shown in yellow just connects to your existing business logic shown in green, and you can choose what functions from your existing web app to expose to provide it with the tools it needs to get jobs done. Now, you can check my Google I/O talk at the bottom there for a deeper dive into its inner workings if you're curious to go further into that. Okay, so with this in mind, I can now reuse this same logic with a different web application that has different exposed tools. And in the example shown here, I made a web AI DJ in just one day of coding by reusing the framework that you just saw. And this works with public APIs for music services to use web AI to basically make your own playlist whatever you want. I even upgraded the text-to-speech engine to use a web AI model known as Kokoro for a more natural sounding voice. The previous one was a bit robotic, right? Now you can try this for yourself at the link at the bottom there, but for now, I'll just show a demo of this in action. Playlist of music suitable for late-night coding sessions that fill and not too many words. And sure enough, in this case, it's able to think about its moment in the world to pick some artists to the criteria I asked for.
All right, let's get those late-night coding vibes going with some chill tunes. To kick this off, Typhoon's dreamy soundscapes are perfect for focusing.
After announcing the track, using the Kokoro web AI text-to-speech model that's also running entirely locally, it then calls the Spotify API to grab a song of the chosen artist, which it then starts playing immediately. And just like that, in less than a day, I've got a brand new prototype just by changing the tools that it can call and giving it a different persona for how to behave when talking to the user. All right, so as you've seen, web AI is the art of using machine learning models client-side in a web browser, running on your own device's processor, graphics card, or even NPU, using JavaScript and surrounding web technologies like WebAssembly, WebGPU, or emerging standards like WebNN for acceleration. And in some cases, the AI base model may even be built into the browser itself and exposed to JavaScript developers via emerging APIs for common tasks like prompting, summarization, and translation. In fact, Chrome is already working on built-in AI APIs that run entirely on the user's device. So that's also a form of web AI too. And you can check their website for more details on that. Now, all of this is different from cloud AI, whereby in that case, the model will be executed on the server side and be accessed via some sort of API instead, which means you need an active internet connection to talk to that cloud API at all times to provide those advanced AI capabilities. Right now, generative AI in the browser is in its early stages, but as hardware continues to evolve, we shall continue to see more powerful models ported to run in the browser on your device, enabling businesses to reimagine what they can actually do on a web page, especially for industry or task-specific situations. So what does this all mean for our future? Well, I believe we shall see smaller large language models in the maybe 1 billion to 9 billion parameter range be tuned for a specific purpose via cloud and then run on consumer hardware to save costs and have privacy. And these smaller models can then provide agentic behaviors like you saw today, and they could be tuned to be really good at things like tool selection and execution, training multiple tools together to solve arbitrary tasks, maybe running as a Chrome extension or even be built into the browser itself. And today, we're at the start of a potential new era, an agentic-powered internet that could really enhance your existing web presence for the services and products that you're already providing to your customers. And the time is now to start exploring how all of you could apply web AI agents to your industries that you're going into. What if, instead of adverts, websites that offer services bid for performing useful work with end users agents instead? This is something I've been thinking about quite a bit this year, how the internet itself will evolve with these things in mind, and I've got a document there you can read in more detail if you're curious about how that might work. So, consider using hybrid approaches today with these smaller local models For example, maybe you've got a vector database of domain-specific knowledge up in the cloud somewhere. You could pair that as a tool with a web AI agent on the client side to provide the critical context to answer a user's request, allowing you to get a more advanced task done that otherwise the smaller model on its own couldn't have done. By using both web AI and cloud AI together, it allows you to get the key benefits of both ecosystems. Now, I'd just like to end by saying there's very few opportunities in one's life to be at the beginning of a new era like this. Now, I, for one, remember when the internet came out for the first time. I am actually that old. And the agentic web AI stuff has the same feels as that, only magnified 1000x. So it's really important for you to realize you're at the beginning of something that very few generations have a chance to be part of. If you take action now, you'll actually be able to shape the future of the world. And I believe that in the future, we'll build AI-compatible websites that expose available tools in a standardized way, maybe via the new web MCP standard that's being defined as we speak. And this is specialized for websites rather versus the original MCP that's designed for command line applications. And with this, you've got the option to then just talk to these websites naturally via text or voice to perform any of the tasks that they support using an AI agent. And that way, the agent can use this knowledge to get a job done in seconds and provide results back to the user in a way that's optimized for them. And that's the key part here. You can have customized user interfaces or customized reading styles, all created in the moment to maximize understanding of the results that come back. And the browser is one of the best places to do this, as you're already signed in to the services and love that you use daily, enabling you to use all of those tools from those services in one place, unlike other ecosystems that don't have that. Mobile does not allow you to interact with all the other domains out there. Now, there's one reason why all this Gen AI stuff started with a web interface. It's accessible by anyone, can be used anywhere, and can connect to anything in the most frictionless way possible. And our kids of tomorrow might find it an alien concept if they can't just explain what they want to do and have it all just completed for them asynchronously in the background to bring their ideas to life. These kids will likely grow up with agents that they can command from a very young age, just like kids from my generation grew up with the internet and tools like Google search. And I was able to ask any question I could dream up and find the answer to that thing. But tomorrow goes beyond just finding the answer and instead is able to use what was found to get the thing that you wanted to do done in the first place. So it takes that extra step. So I hope in this talk, I've been able to provide you with a tiny glimpse into the future and why you should start investigating web AI today, because everyone here in this room has a chance of a lifetime to really shape the future of everything that you're working in for this fast-growing client-side AI space. So I hope all of you will join me on this adventure. And of course, do tag me in anything you make, or if you've got any questions or suggestions, you can connect with me on social media. And of course, we're going to have some time here for some Q&A live whilst I'm here in town. But if you do make something, use the web AI hashtag so we can find it and help you share it to get it in the eyes of many people. Thank you, and time for Q&A. Thank you. Okay, so if you've got any questions, it can be about web AI or Google, I guess. Feel free to raise your hand. Yeah.
I can act.
Yeah, sure. Yeah.
Sorunuz varsa alabiliriz arkadaşlar. Sorunuz varsa.
First of all, thank you for the presentation. We appreciate you a lot coming here today. I just had a question. We utilize already trained models in JavaScript and web. How do we actually utilize the trained models? I was asking the logic behind it.
Is this on? Testing? Oh, okay, cool. So there's a whole bunch of trained models out there that you can reuse. If they're currently in Python land, you'll need to convert them to be in a web AI format that can run in the browser. There's many tools out there that can help you convert. We've got some, if it's in TensorFlow, we can convert to tensorflow.js and then run by a web GPU in the browser very fast. If you're on PyTorch, you can convert quite easily to the Microsoft Onyx format. And there's a new runtime called Microsoft runtime web, on its runtime web, which allows you to run in the browser for that as well. So depending which path you're coming from, you might find some formats easier to convert to than others. But it is up to you to quantize and prune the model to make it as fast as possible on the client-side device, which obviously will probably be less powerful than a server with multiple GPUs. But you'll be surprised, as you've seen from the example today, how many models do run very fast in the browser if you quantize them and do the right thing. Yeah, great question. Thank you. Any other questions? Don't be shy. It can be about Google or Web AI. It doesn't have to be a technical question. Can be either. Yeah.
Türkçe'de sorabilirsin bu arada. Sıkıntı yok. İzleden yapıyorsun.
I'll add one more thing. Okay, I'll add one more thing. Those who do raise their hands might receive a prize.
I think it's for so Mr. I would like to ask a question that is not technical. It's here.
Oh, thank you. Yeah.
I was about to ask, since you came from San Francisco, Bay Area, my question is, which field in tech are is going to rise? Because and another question is, the web market is going to decrease for software engineering,
Okay. Yeah.
software development.
Sure. Great questions as well. So, now this is my personal predictions, not Google's. Just to be clear, this is what I've observed by living in the Bay Area. First of all, I take self-driving cars everywhere now. I do not use a human to drive my car anymore. Okay, that's a solved problem as far as I'm concerned. So I think we'll see a shift in that kind of stuff. And it also could be an interesting area to be involved in terms of research and stuff like that going forwards. I also see the robotics industry taking big leaps right now. I think we can all agree from the videos you see online that the dexterity of these robots that can do backflips and all these kind of things is very, very impressive and is much further along than what I would have predicted just 5 years ago. But they still require some good research for the brain of these robots to do things in the real world, understanding the physics of things and the 3D nature of the world around us. So I think there's a big opportunity for people like yourselves to research into those areas to make these very cool robots be smarter and actually do useful things in the world around us. And that's a very big growing space. Looking further towards the future, maybe 10 years plus, quantum is a very interesting area as well. Now, quantum is not going to be solving everything that classical computer science does, but that's an emerging field that, especially in the sciences, has some applications that could be very interesting and one to keep an eye on as you all progress through that era too. So I think those would be my top 3 areas for now in my mind that I see making big leaps that maybe over this side of the world you don't see as much of day to day, but something to definitely keep an eye on as it's moving very quickly. And then the second question was around, I guess, job security and things like that, right? So I think that there's going to be a shift in maybe how we do things. So I, for one, being a very old school engineer, 20 plus years engineering experience, I would never vibe code, okay? I'm not vibe coding. And then Gemini 3 came out just a couple of weeks ago, and I tried it out, and the results were so impressive that I now am considering delegating some things to Gemini 3 to implement. So what does that mean for me as an engineer? I think it means that I can be more productive, but I'm still utilizing the knowledge I gained in my computer science degree to learn how to break down problems, how to think creatively, to work with unknowns, that kind of stuff will be still very important. But you'll be able to, as a single person, have maybe an army of AI agents doing a lot of the grunt work for you, and you can focus on the higher level problems and breaking down the tasks into subtasks and making sure things are secure and scaled correctly, that kind of thing. So I think it might shift our minds in how we work with these technologies, and it might require some reskilling here and there. But I think overall, if used in a positive way, it could allow us to be more productive. So yeah, great question. Thank you.
Thank you very much.
Okay, one more question. The lady in the stripe was first. Yeah.
Hello, Mr. Mason. Thank you for your speech, first of all. So, you mentioned that in order to prevent hallucination in LLM models in web AI, you use APIs to basically receive live data. Now, for people who want to incorporate AI, machine learning, LLMs, etc., into fields that are kind of outside of web, like UAVs in my case, how do you recommend that we prevent hallucination? What do you think I can try and learn to basically incorporate that?
So in that case, you can still have local databases and tools that access the local databases. So maybe it's not the most current information of the world's status, but you've got like an update before you take off with the drone that you can use whilst it's on the fly for that hour or two that it's flying around. So something like that might be the approach to take there. So you've got recent information that's good enough for the situation. And yeah, that's the only thing you could do there. If you don't have a cloud connection, then you'd have to have some local cache of that data to utilize with the generative model. I'd also recommend using non-generative models for mission critical things like object detection. Like I see a lot of people using multimodal models for object detection. And whilst it is technically possible, you probably want to use something like the YOLO model, which is much faster and uses less power and all that kind of stuff, which for drones actually could save a lot of battery life and that kind of stuff, right? So yeah, using the right model for the right thing, and then only delegating to the generative AI for things that, if there is a hallucination or something, you can mitigate, or it's not a mission critical task, I guess, in that case. Yeah.